Savage Sullivan Math here. Today we are looking at the zero exponent rule. When something is raised to the power of 0, it's equal to 1. So you see here this whole wonderful fraction here is all raised to the power of 0. We could do the power to a power rule and multiply these corresponding exponents, and we would get 0 for the remaining exponents for each of them. This would be x to the 1 times 0, which is 0, y to the 4 times 0, which is 0, z to the 5 times 0, which is 0. That would just be very cumbersome. So it's nice to know that when the whole thing is raised to the power of 0, all we have to say is that it is equal to 1. So that one's nice. If we look at this one that's right next to it, this has a little bit of extra work for us. One thing we do notice is that this base of y has an exponent of 0, which means that y to the 0 power is just essentially 1. So we are looking at x squared times 1 times z in that first parentheses. Well, as you know, we don't always have to just write something as multiplied by 1. You can just really drop it because it's the same thing as saying x squared times z. So our problem is now x squared times z multiplied by x to the 4th times z cubed. All right, one thing we notice is that we have like bases of x's right there and like bases of the z's right here. Remember the product of exponent rule, where if you have the same base that are being multiplied by each other, all you have to do is add these exponents. So this problem is really the base of x with the exponents of 2 plus 4, which we know is 6, and then the base of z with the exponents of, remember this is an assumed 1 right there, 1 plus 3, which is 4. So there you have it. Final answer, x to the 6th times z to the 4th.
Great work, Mrs. Sullivan. So what happens with a problem like this? Well, overall, I know my problem is division because anything written as a fraction is really division. And there are multiple ways we can approach this problem, but I'm going to start by looking at my numerator, and I'm going to see if I can apply the product property anywhere in my numerator. Because I'm multiplying, I'm going to make sure that my bases are the same before I go ahead and add any of my exponents. We run into a problem because none of these bases are the same, so I cannot apply the product property in the numerator. I'm going to ask myself the same question in the denominator. Are any of these bases the same? Nope. So I can't add any of the exponents together. So the next thing that stands out to me when I look at a problem like this is the 0 exponent. As we've learned, anything to the 0 power is just 1. So I'm actually going to go ahead and with my highlighter, I'm going to just cross this out and I'm really going to just write a 1 above it because we know that's really 1. Same thing in the numerator. T to the 0 power is really just 1. So that makes things a little simpler because we know when we multiply by 1, nothing changes. So now I'm going to go ahead and I'm going to apply the quotient property. So we know when we divide things that have the same base, we can subtract the exponents. So r squared divided by r squared, well, that's really 2 minus 2 now. So we get r to the 0 power. We'll come back to that after. Next, we're going to work with the s. S to the 7th divided by s cubed. We're going to subtract the exponents since the bases are the same. So that would be s to the 4th power. And now we're going to look at t. Well, because we made this a 1, we only have this t cubed at the top. So that's just going to come down and become t cubed. Now, if I hadn't changed this to a 1 at the start, I could do 3 minus 0, which is still going to get me to t cubed, so it doesn't change anything. So now I can do one more thing. What do you think that is? Yep, that r to the 0. What do we know anything to the 0 power is? It's really just 1. So my final answer, when I simplify everything down and write it as compactly as I can, I don't have to write the 1 here. So my final answer is just s to the 4th t cubed. And again, I can't combine those because the bases are the same. So, are not the same rather. So we are done. If you found this video helpful, please like and subscribe.